The way wars are fought is changing fast. For decades, aircraft carriers have ruled the seas, armed with powerful missiles, artillery, and advanced fighter jets. But a new kind of threat is rising, one that even the most advanced defenses struggle to stop: hypersonic missiles. These weapons travel at speeds 10 times faster than sound, making them nearly impossible to intercept. The US military knows that traditional defenses won't cut it anymore. That's why they're betting big on a weapon unlike anything we've seen before: combat lasers. Mounted on a floating nuclear powerhouse, this new technology could completely change how naval warfare is fought. But can it really stop unstoppable missiles? Or is this a desperate attempt to keep aircraft carriers relevant in a world where hypersonic weapons threaten to make them obsolete? At the heart of this technological revolution is the Gerald R. Ford-class supercarrier, the most advanced warship ever built. This isn't just an upgrade. It's a radical redesign of what an aircraft carrier can be. The program started under CVN-21, with the U.S. Navy requesting $1.5 billion in 2004 to kickstart the project. But as development progressed, the costs skyrocketed. By the time the first ship, USS Gerald R. Ford CVN-78, was completed, the price had ballooned to $12.8 billion, plus another $4.7 billion for research. That's a $17.5 billion investment into a single warship. But why spend so much? Simple: this carrier is a fortress like no other. This 100,000-ton giant is 1,160 feet long, making it one of the largest ships ever constructed. Its deck can hold up to 90 aircraft, including F-35 Lightning IIs, Super Hornets, Growlers, and combat drones. But raw size isn't what makes this ship terrifying. It's what's under the hood. The Ford class was built to power the next generation of weapons, from electromagnetic catapults to directed energy lasers. And it's the only warship in the world with the energy capacity to support them. So, what makes the Ford class so special? First, let's talk about power. The old Nimitz-class carriers were built in the 1960s, and while they were ahead of their time, they simply can't handle modern energy demands. The Ford class fixes that with two A-1B nuclear reactors, generating 25% more power than its predecessor. That's more than 600 megawatts of energy, enough to power a small city or multiple high-powered laser weapons. And this isn't just theoretical. The Ford class was designed with future upgrades in mind. Then there's the Electromagnetic Aircraft Launch System, EMALS, a huge leap from the old steam catapults. Instead of using brute force, it uses electromagnetic rails to launch jets faster, smoother, and with less stress on the airframe. This means longer aircraft lifespan and higher operational efficiency. Landings are also upgraded with Advanced Arresting Gear AAG, replacing the outdated hydraulic system with electromagnetic motors for safer, more reliable recoveries. Even ammunition handling has been revolutionized. The Ford class uses electromagnetic weapons elevators, cutting down rearmament time from hours to just minutes. Every part of this ship is built for speed, efficiency, and power. But the real game changer is in its defensive capabilities. A warship is only as good as its ability to detect threats. The Ford class is loaded with some of the most advanced sensors in naval history. The dual-band radar, DBR, originally designed for the Zumwalt-class destroyers, can track multiple threats simultaneously, including low-flying cruise missiles and high-altitude hypersonic weapons. It's like having a supercomputer for air defense. However, not every Ford-class carrier will use DBR. The second ship in the class, USS John F. Kennedy, CVN-79, replaces it with the Enterprise Air Surveillance Radar, EASR. A cost-cutting move that saved the Navy $300 million. But it's not just about radar. The Ford class is armed with two RAM launchers, ESSM missiles, CIWS Gatling guns, and heavy machine guns. Sounds impressive, right? Well, even this might not be enough against hypersonic threats. Right now, the biggest challenge for naval forces isn't submarines, jets, or conventional missiles. It's hypersonic weapons. These missiles are so fast that traditional defense systems can't react in time. Take the Chinese DF-21D, a hypersonic carrier killer that moves at Mach 10 and can strike from 1,240 miles away. By the time a carrier detects it, it's already seconds from impact. And China isn't alone. Russia is also developing Zircon hypersonic missiles, and the US itself is racing to build its own hypersonic arsenal. So what's the solution? Speeding up defenses isn't enough. The Navy needs something that can strike back instantly. The answer? Lasers. For decades, military defense systems relied on missile interceptors, high-speed guns, and electronic warfare to take down incoming threats. But when facing hypersonic weapons, those traditional defenses become useless. A missile moving at Mach 10 is simply too fast for any radar-guided interceptor to react in time. The moment it enters detection range, it's already seconds away from impact. That's why the US military is shifting toward a weapon unlike anything ever seen before: laser-based defenses. Unlike missiles, which cost millions per shot, lasers offer a cheap, fast, and limitless solution. A single laser pulse costs just a few dollars. The real power of lasers comes from their speed. They don't need to calculate intercept trajectories or predict missile paths, because they move at the speed of light. The second an incoming threat is detected, a laser can fire and hit it instantly. The US Navy's biggest bet right now is on free electron laser (FEL) technology. This isn't like the lasers you see in sci-fi movies. It's a high-energy beam capable of heating and melting a target mid-flight. FEL systems use electrons accelerated through a magnetic field, creating a powerful, precise energy beam that can target weak points on hypersonic missiles such as guidance systems, fuel tanks, or control surfaces. Even if the missile isn't fully destroyed, damaging its flight systems is enough to throw it off course, making it easier for other defenses to finish it off. But here's where things get even more interesting. The Ford-class supercarrier is the perfect platform for these weapons. Unlike destroyers or smaller ships, which have limited power generation, the Ford class has 600 megawatts of nuclear power at its disposal. That's enough energy to supply an entire city, but more importantly, it's enough to power multiple high-energy laser systems at once. The ship could run 500 kilowatt to 1 megawatt laser weapons continuously without draining its energy reserves. The only real challenge? Getting these systems installed and operational before hypersonic missiles become too common. This isn't just theory, it's already happening. Over a decade ago, the USS Ponce tested a 40 kilowatt laser and obliterated a drone, a boat, and even a rocket-propelled grenade. Fast forward to 2024, and the USS Preble just successfully tested the Helios laser, a 300 kilowatt weapon designed to take down aerial threats with ease. The next step: mounting these weapons on supercarriers. If the USS Ford gets a 1 megawatt laser, it would become unstoppable, a warship capable of defending itself against any missile, drone, or aircraft before they even get close. But will this actually happen? Or will military bureaucracy slow things down? The future of naval warfare is unfolding right now. The world is watching, and the next few years will determine who dominates the seas. What do you think? Are laser weapons the key to unstoppable defense? Or is this just military fantasy? Let us know in the comments below. And if you enjoyed this breakdown, don't forget to like, comment, share, and subscribe for more deep dives into the most mind-blowing military tech. Thanks for watching, and we'll see you next time.